Welcome all. Now I am going to discuss question number 35 from the GATE 2021 paper Electrical Engineering. A 3-bus network is shown. Consider generators as ideal voltage sources. If rows 1, 2 and 3 of the Y-bus matrix corresponds to the bus 1, 2 and 3 respectively, then the Y-bus of the network is. These are the given options. To know the detailed formulation of the Y-bus matrix, audience can go through the given NPTEL course or the video link. Let us discuss briefly how Y-bus can be formed. From the matrix itself, we can say that diagonal elements can be formed by summation of all the admittances that is connected at each node respectively. Similarly, off-diagonal elements are the negative admittances that are connected between the corresponding buses. Here, one extra node is given. So, let us name it as Vx. Since extra node is given, we can't solve the Y-bus matrix using conventional method. So, we will solve from the basic method, that is KCL. So, apply nodal analysis at each node. Node 1, this is the current going from bus 1. This is the current going from bus 2. Similarly, I3 is the current going from bus 3. And Ix is, this is Ix. So, at node 1, I1 is equal to V1 minus Vx by Z1, that is J. Similarly, I2 is equal to V2 minus Vx by J. And I3 is equal to V3 minus Vx by J. And Vx is equal to Ix into J. And Ix is the summation of I1 plus I2 plus I3. So, if we substitute, Vx is equal to I1 plus I2 plus I3 into J. Substitute I1 in Vx. So, Vx is equal to V1 minus Vx by J plus V2 minus Vx by J plus V3 minus Vx by J into J. So, Vx is equal to V1 plus V2 plus V3 minus 3Vx. So, Vx is equal to 1 by 4 into V1 plus V2 plus V3. We need to substitute the Vx value in I1 and I3. Substitute Vx in I1, I2 and I3. So, if we substitute I1, we know that I1 is equal to V1 minus Vx by J. So, V1 minus Vx is 1 by 4 into V1 plus V2 plus V3 divided by J. we simplify. This is 3 by 4 V1 plus minus 1 by 4 V2 minus 1 by 4 V3 divided by J. So if we multiply and divided by J, we will get it as minus 3 by 4 J V1 plus 1 by 4 J V2 plus 1 by 4 J V3. This is I1, right? Similarly, we have to find I2 and I3. In I2 also substitute Vx. That is V2 minus Vx is 1 by 4 V1 plus V2 plus V3 divided by J. If we simplify this expression, we will get minus 1 by 4 V1 plus 3 by 4 V2 minus 1 by 4 V3 divided by J. So if we further simplify this expression, we will get 1 by 4 J V1 minus 3 by 4 J V2 plus 1 by 4 J V3. Similarly, we need to find I3. I3 is equal to V3 minus Vx. Vx is 1 by 4 V1 plus V2 plus V3 divided by J. So finally we will get one by 4 J V1 plus 1 by 4 J V2 minus 3 by 4 J V3. So I1 is minus 3 by 4 J V1 plus 1 by 4 J V2 plus 1 by 4 J V3, and we got I2 as 1 by 4 J V1 minus 3 by 4 J V2 plus 1 by 4 J V3, and also we got I3 as 1 by 4 J V1 plus 1 by 4 J V2 minus 3 by 4 J V3. So if we write this thing in matrices form, I1, I2, I3 is equal to minus 3 by 4 J, 1 by 4 J and 1 by 4 J. Here 1 by 4 J minus 3 by 4 J and 1 by 4 J. Similarly, this one is 1 by 4 J, 1 by 4 J and minus 3 by 4 J into V1, V2, V3. V1, V2, V3. This is the Y bus we got. Matrix we got is same as the option C. So option C is the correct answer. Thank you.